So I'm repairing this Accuphase E-202 amplifier. I had some problems with this unit. Currently most of the boards are unplugged. Mind when plugging and unplugging the driver boards to discharge the capacitors. So you can put a, for example, a high voltage lamp between the collector and the chassis. And, so the plus and the minus collectors are here. So between this point and the chassis, connect the resistor. When the amplifier is turned off, wait a little bit and then measure between this point and chassis and this point and chassis that the electrolytic capacitors are empty, because when inserting boards, when the capacitors are loaded, I'm not sure if it's a good idea. So let's go to the boards where the problems are. So those are the two identical driver boards, and this is the fault protection relay board, and it has the rectifier for the high voltage, because this amplifier, it runs on 55 volt and an 85 volt. So I'm part of the driver. Actually this one with the common collector output is running on the high voltage, and also the high voltage is used for the stabilized 40 volt, the regulated voltage for the small signal boards like the phono amplifier and the tone board. It uses the regulated 40 volt, but anyhow, starting with this board, I got it with almost all capacitors replaced, and it are all audio grade or high quality Vichy capacitors. Now I don't think that makes any sense to use the audio grade expensive capacitors only for the timing capacitors for the relay. So that's that. So when first turning on the amplifier, the fuses which are below here, so behind the meters, were blowing. So every time I turned it on, the fuse blew, and that was caused by this rectifier. It was here in between. It had a short. So what caused this, I don't know, because the input of the rectifier is just protected by a 1 amp fuse, so it cannot get that much current, even if there is some problem further on in the circuit. So now it's not replaced by the original. I just put 4 diodes in there, so it's not real original, but I think this one, it has a higher rating. It's the 1N 4007 diode, so it can handle the 1 amp of the fuse without any problems. So this board has been partly restored by the previous owner, so almost all capacitors were replaced. What I didn't do was resolder the dry solder joints. So at this hot part I reflowed the solder joints because they were really dry. So that's good now. And yeah, mostly the smaller, with this amp my experience is only the smaller capacitors are getting weak. So So yeah, just check for the smaller ones that are more likely to be dried out, I think, because there's just less fluid inside. So that's that board. Then I had here one channel at burnt. So you see here that the resistor was completely burnt, and all the output transistors were fried. So what caused this? Of course, you can have a overload problem, maybe the speaker went bad, so it is an external problem. But yeah, then again, the circuit is protected against overcurrent by those two transistors. So it's always interesting good to know whether the problem that caused one channel to completely burn, if the problem was external or internal. So when you are replacing all transistors and you turn it on again, that if you didn't find the internal problem, then it just all burns again. So I measured all the transistors in circuit just using a test lamp and putting let's say 1 kilo ohm on the base, and see if the transistor starts conducting and stops conducting when applying a small current to the base. So I just measured all the transistors here, and doing this I discovered a real bad problem, and that is that this thermistor was conducting to the metal here, and what happens, this thermistor was mounted there. The case of this transistor is connected to the voltage rail, to the 55 volts, and with this lid was conducting to the thermistor what it should be isolated, but it was conducting, injecting 55 volt into the bias circuit, turning on one of the drivers, and that way blowing the end stage of the amplifier. So I'm going to show you that this one is indeed conducting from there. I have to do this one-handed. There to there. It's 60 ohms, and it should be completely open, of course. So that's real bad. So I discovered that before applying power to it with my new transistors in. So what I did already to the other channel, I made, it's not real beautiful, but I made an isolation between the thermistor and the transistor. And I don't know if you can see it, but below is a little bit of transparent, a little bit of mica that I cut out from just TO3 mica. So it's isolated, so this is just preventive, but because this thermistor was good. And now I'm going to do the same thing with this one, so it's never going to make any short circuit in the future. This one, it measured good, it's about 1 kilo ohm, and it drops when you apply heat, so it's the function is working. And there is another thermistor, of course, on the heat sink. So this is measuring the temperature of the driver, and the other one of the end stage. Okay, now when redoing such a board, I always put the bias control on minimum. Now this is a 100 ohm bias control. I put it on 10 ohms, so let's say near minimum, and then apply power to the amplifier with a variac, measuring the bias, it's on this point, and then increase power to the line voltage and then you can adjust the bias. I first check that it's not like noisy, because if there's noise in the potentiometer, yeah, you can have spikes on the bias, which is bad. So on this board, this had burned, all the outputs, those are the original ones. Those are just temporary for testing, so I ordered the original ones, the 3 watt 1 ohm emitter resistors. This one was also bad, the 56 ohm. This one has to be a fusible resistor, and that really protects your driver, so if anything goes wrong, the fusible resistor will protect your driver. So in this case everything was still in working order, so the semiconductors there. This one was bad. Capacitors were good except for this one. This one is connected over the xenon diode. It's a 1 microfarad electrolytic. It was completely open, it didn't do anything. So also for the other channel, yeah, I could have mounted it here, because it's heated and dried up. The inside just evaporates by the temperature of the 2 resistors, so maybe I could have better put it out of the way, but this way it looks as original as possible. So I think that's about the driver. And those two were bad too. It was originally the protection transistors. They are measuring the voltage drop across the emitter resistor, and if the emitter resistor goes open, yeah, then this one blows immediately. So I think that's about this boards. Now then, about the failing transistors. This one was only 2 out of 4 failed. Still a good one. And this one I opened up. You see that little black spot there? No, it's completely shorted. So it's going from collector to emitter to base. It's all 0 ohms, shorted in all possible ways. And that's why everything in front of it and behind it will get fried when this one blows. Then I replaced it, mind the area of the actual silicon. I replaced this one with the Motorola MG 150 25 and 24. Voltage is much higher because the original, the Toshiba, it is 120 volts, and the Motorola is 250 volts. So yeah, don't go below the 120 volts. So you can see the Motorola has a somewhat larger piece of silicon in it. So, and the gain is about 50-60, so it's about the same as the original one. It's the R. The R means low gain. It's also about 60 HFE gain. So that's good. That's good. Just don't replace it with a lower voltage rating or lower current rating. So yeah, I think that's it. Any more capacitors?